If we want to get more advanced, we want to talk about machine learning. Now, machine learning is super powerful. Machine learning is very powerful, and also it's very simple. This is basically how machine learning works. Okay, so I'm taking a behavior in a dog. Say I get a puppy, one of my 6.5 pets. And I say, okay, I'm going to teach this puppy how to do things that aren't natural behaviors for puppies, like sit up or roll over or beg or whatever, play dead. Those are not natural things for dogs to do. How do I teach a dog how to do something that's not a natural behavior? Well, I take the dog and I kind of wait for it or trick it somehow into doing something that's similar to the behavior that I want it to do. And then when it does that thing that's similar to the behavior I'm trying to get, what do I do for the dog? I give it a little treat, right? Give it a little bone or treat or piece of cheese or whatever. I guess if I give him a piece of cheese every time, he's going to get fat really quick. But if I do that, then eventually I get the dog to do what I want it to do because it's formed an association between me saying sit up or shake or whatever, or me doing a certain like motion with my hand or whatever, and it doing the trick. Machine learning is basically exactly that. If you take that and you multiply it times 1,000 or 1,000,000, you're teaching a dog how to do a very complex set of behaviors. Here's an example that's super common. If you take a machine learning class, you'll be so sick of this stupid iris data, you're going to throw up because this is the example. In fact, it's so popular that it's included with some of our machine learning libraries. But basically, it is a good example because it's something that feels pretty complex. And what it is there are three species of iris flowers. They all look pretty similar. They're all kind of purple with a little bit of yellow in there. They got the same kind of shape. They're the same, they're subspecies, is the technical word for it. They're all irises, but we have Iris setosa, Iris versicolor, Iris virginica that have different things about them. And the primary way that you can tell one species of iris from another is by measuring the sepal and the petal, which are different parts of the iris flower. I think the sepal is when the flower is a bud, it's the part on the outside, and the petals are what's inside that. And when it opens up, it looks like that. So if you measure the length and width of the sepal and the petal for these iris flowers, and you plug that into a machine learning model, you can actually teach a machine learning model to guess with almost perfect accuracy what kind of flower, what subspecies of iris flower you have. So this iris data that's built in, if I were to visualize that data, it would look like this. And let me explain it to you, but you can kind of see what's going on here. You've got Setosa, versicolor, and virginica as represented as orange, or blue, orange, and green dots. And what you have is each one of these little squares with the scatter plot in it shows you the petal length on this one. So this row is petal length, and it's charted against sepal length. So the sepal length is this axis, and the petal length is this axis. You don't really need to get too much into the weeds here. These are a histogram that shows the petal length by the petal length as a histogram. So the higher that point is, the more flowers that were tested in the test data had that exact length. So you can see there's a pretty big spike there a pretty big concentration of that flower versus the other two kinds. You can kind of see that visually, if you plot this data, you can kind of see what's going on here. You can see, especially with the Setosa, that it's quite different than the other two varieties. And you can also see that in some places, there's a lot of intermingling between the other two kinds. So if you just had the measurements of a single flower and you only had some measurements, it might be pretty difficult to tell which one is which. But if you take all of this data and you plug it into a machine learning model, and then you give me the measurements, the sepal length, the petal width, and sepal width, those four measurements for any flower, I can tell you with almost 100% accuracy what that flower is going to be. And the way it results, or what it results in, and I'll show you here in just a minute, is something called a confusion matrix. And the confusion matrix says, I'm going to take some test data and I'm going to guess. After I've trained my machine learning model, I've trained the puppy, I'm going to say, okay, now I'm going to give you some test data. And I want you to guess at what it actually is. And then I'm going to tell you if you were right or wrong. And so when I gave it 40 of the Setosa samples, it correctly identified them as Setosa 40 times. It made zero errors it did not think any of them were this kind. It did not think any of them were this kind. When I gave it the versicolor variety, it correctly identified 30, and 3 of those flowers it incorrectly identified as this kind. And you can see the switch here. But if you have a strong machine learning model, your big numbers are going to be in these diagonals, because these are the ones, the bold ones here, are the ones where it guessed correctly. So that says to me, oh, I trained it with enough data that it can make sense. So what does it look like?